Okay, hello guys, hello everyone. Grade 8 and 9. Guys, this is always for grade 8 and 9. Remember that, as I have been saying to you, grade 8 and 9 are pretty much, we are talking about the same things, under the same different conditions. So, guys, I want to slightly start, I don't know. It's Chris. I have no idea. You guys are asking me. I have no idea. All right. Remember that I stay in one location, one province. Thank you so much, Mr. STR. What ST is it? STXR Starlit Lux. Mr. Luxembourg. Thank you. Thank you for the rose to open up the session. Wow. Okay. Yeah, people are unleashing the roses today. Thank you so much at the beginning. D'Angelo Brown. I really appreciate it. Save us for tomorrow. Save us for tomorrow. Yes. What's the meaning of save us for tomorrow? Yeah, well, guys, like I said, how to calculate the hypotenuse in a right angle triangle. Okay, I'll quickly explain that to you. All right, I think we'll be playing that game today. Isn't that so? We're playing the game of spot checking questions. Okay, so let's look at a little bit of Pythagoras, because it seems like Pythagoras, even when I finished the live yesterday. Okay, please do reflection. I'll look at that. Okay, let's just quickly look at some Pythagoras. Yes. Pythagoras is part of geometry. Okay, I think people don't really get to they don't understand that Pythagoras is part of geometry. So if I'm doing geometry, I'm doing Pythagoras. If I'm doing Pythagoras, I'm doing geometry. Okay. Yeah, area and perimeter is also there. Right, so let's just hang tight. Allow me please. Allow me to do the following, please. If you can, if you will. Okay, Pythagoras is for grade 8 and 9, guys. Pythagoras thing is for both grade 8 and 9. Okay. I'm going to look at a few questions around that. Okay, so that you guys can actually appreciate this here. Okay, let's come here. The theorem of Pythagoras. Okay, as it is one of the topics. We have a paper here. This is one of the papers that was written in previous years, grade 9. Okay, complete the theorem. In a what type of angled triangle? The square on the hypotenuse is equal to the what of the squares on the other two sides. Fill in the blanks. In a what angled triangle? The square on the hypotenuse is equal to the what of the squares on the other two sides. Do we all know, guys, the words that are missing in this beautiful statement that we have here, grade 8 and 9? Ain't Karabo, thank you so much. In a right angled, right? In a right, okay, angled is already there. In a right angled triangle. The square on the hypotenuse is equal to the what? Okay, is equal to the sum. Thank you so much. Who's that? Who said that? Who said sum there? D'Angelo Brown. Yes, is equal to the sum of the squares on the other two sides. That's what the theorem of Pythagoras says. Guys, I hope you know what this theorem says and what it actually means. This is an important statement. Grade 8s and 9s, you need to know this statement. In grade 8, in grade 9, in grade 10, in grade 11, in grade 12, if you are going to be a pure math student, technical math student, and so it goes. So please guys, in a right angled triangle, the square on the hypotenuse. What is the hypotenuse? The hypotenuse is the longest side of the right angled triangle, and it is also the side that is opposite 90 degrees. They say that that side, the square on that side is equal to the sum of the squares on the other two sides. So let's come down here. Find x and y. Show all calculations. So we want who? X, all right? And we can see x is part of. Now let's look at the entire diagram. How many triangles do you see in this diagram, guys? This is very important when you do questions of this nature. How many triangles do you see here in this diagram? Dimples, thank you so much. Dimple says 3. D'Angelo says 2. Not him says 2. Operation Kabaz says 2. Stamen Gaming says 2. Lutoluwaka says 3. Guys, I want to say that there are 3 triangles. Let's identify them. There is triangle JKL. Here it is, JKL. Then there is triangle JLM. And then there is triangle JKM. Triangle JKM. So there are how many triangles in total? There are 3 triangles. But how many triangles are right-angled triangles? Maybe let's ask that question. First, I asked how many triangles there are, but how many right-angled triangles do we have? Shanti Live is laughing so hard. Thank you so much, guys. There are 2. 2 right-angled triangles. Which are those right-angled triangles? Those right-angled triangles that we are saying there are 2 of them is triangle JKL, and also triangle who? JLM. So there are 2 right-angled triangles. Now I know some of you said there's only 1, and the reason why you said 1 is because you're seeing JLM being the only triangle that has a 90-degree angle. But remember guys, if JL has this 90 here, because this is a straight line, we know that this angle as well will be what? Will be 90 degrees. Why? Why is this angle also going to be 90 degrees when this one is 90? Why is also this one going to be 90? These angles are adjacent to each other. They lie on a straight line. So if that is 90 and this line is perpendicular to this one, it stands to reason that this angle is also 90. So if that is 90, angles on a straight line, we know they complete 180 degrees if they share a common vertex L. So this is also 90. That is why we say there are 2 right-angled triangles. JL is perpendicular to KM. And though the box is on this side of this triangle, we know that the box is also applicable to this right-angled triangle. So, with that said, can we find the value of x? Yes. Why? Because in which triangle? Triangle JKL. And I want to say JKL. In triangle JKL, what do we have? We are given two sides, JL and KL. And there is one unknown side, which is X. So because this is a right angle triangle, we can find X. What is the side X called? We call this side the hypotenuse. Why do we know that this is the hypotenuse? Because the hypotenuse is always located front opposite of our 90-degree angle. I repeat, why do we know that this is the hypotenuse? Because in a right angle triangle, our hypotenuse is always situated front opposite the box 90 degrees. So we know this is the hypotenuse. According to Pythagoras, what do we know about the theorem of Pythagoras? In a right angle triangle, the square on the hypotenuse. So the square on the what? The hypotenuse. In other words, x squared is equal, they are saying, the square on the hypotenuse is equal to the sum. What is the sum? The addition, the plus sum of the what? Of the squares on the other two sides. What are the other two sides? The other two sides are JL and KL. So if they are saying the square on the hypotenuse, that is x squared, is equal to the what? To the sum of the what? Of the square on the other two sides. The other two sides are 16 and 12. So we say 16 squared plus 12 squared. And when we are done, we write the reason, Pythagoras, as our reason for saying the following. Then we can calculate the value of x. We then grab our beautiful calculator, guys, and we use that calculator to assist us in being able to arrive at the beautiful answer. So you then say 16 squared plus 12 squared in your calculator, and your calculator should work wonders, right? It should work beautiful wonders, that calculator of yours. Beautiful wonders. Okay. You type in 16 squared plus 12 squared, just like that, and then bam, what you get? 400. You see, just like that, bam. But we want x, so what do we do, guys? We take the square root, because x is what we want, not x squared. Okay, why do we take the square root? The reason why we take the square root is we want to get rid of the square so that we can get the value of who? Of x, right? The initial reason why we said the square on the hypotenuse, x squared, is because, like we said, in Pythagoras, in a right angle triangle, the square, there it is, you square the hypotenuse. That is equal to the sum, the plus of the what? Of the square. You square the what? The other two sides as well. So that's why we have x squared is equal to 16 squared plus 12 squared. You write the reason, Pythagoras. Then you solve. 16 squared plus 12 squared, we get 400. Then we take the square root, guys, on both sides. We take the square root initially for x squared. Why? So that we can cancel the effect of square there and have x isolated. Then what's the square root of 400? It is 20. And because there are no centimeters, millimeters, or meters, we simply just write 20 units. And that's it. That is our final answer. So x, we now have the value of x, and we can update our information on the diagram. Then we want the value of y. Make sense? We want the value of y. Here is y. We have JL and we have KM. Z, you're asking the same question and I've been explaining that question. You see, people, if you are in the comment section and you type something and you don't listen when I explain, then you are really, I'm not going to lie to you, you are wasting my time and yours. You asked me, why did I square the numbers? And I explained to you why I squared the numbers. The theorem says so. In a right angle triangle, please listen. Guys, if you don't listen, you are wasting my time and yours, honestly speaking. You need to listen and pay attention, because if you're not listening and paying attention, I don't know, all right? You're asking, why did I square the x? Why did I square the 16? Why did I square the 12? Okay, why? The theorem says so. In a right angled triangle, okay, in a right angled triangle, the square on the what? On the hypotenuse. Go to the triangle. This is a right angled triangle. We want the value of x for this right angled triangle. There is a 90-degree angle there. Opposite the 90-degree angle, we explained earlier on that opposite the 90, there is a side that we refer to as the hypotenuse. It is the longest side of the triangle, the right-angled triangle. So the theorem then says, in a right-angled triangle, the square on the hypotenuse. So that's why I'm taking the hypotenuse, which is what? X. And then I say x squared. Okay? Then what does the theorem further say? It says the square on the hypotenuse is equal. Followed by the x squared, I write my equal sign. To the sum. What does the word sum mean? It means plus. It means addition. So the square on the hypotenuse is equal to the sum. This is sum plus addition. That's what sum means. If you use the word sum, it means you are saying addition. It means you are saying plus. So it's the sum of the what? The sum of the squares. Now, you see in English, squares, meaning not one square, but squares, many. This side and this side, 16 squared plus 12 squared. This is the sum of the squares of the other two sides. Other two sides. Other two sides. That's what the theorem says. So that's why I have x squared equal to 16 squared plus 12 squared. Then I write Pythagoras. That's the theorem. Then you take your calculator, you punch in 16 squared plus 12 squared. You get 400. Okay? And there it is, 400. But then we don't want x squared, we want x. So how do you get rid of the squared? You take the square root, because the square root is the inverse or the opposite of the square. It will have a cancellation effect on the square. So you take the square root of the square so that the square disappears and you are left with x. But remember, in an equation, what you do on the left, you must do on the right. So you take the square root on the right side as well. What's the square root of 400? Your calculator gives you 20. This is the value of x, the hypotenuse. It is 20. All right? And therefore, we have 16, we have 12, and we have 20, the hypotenuse side. So then we now have the value of x. We update our diagram with the new information. We move on. They don't want just x. They want y. Where is y? Here is y. What is y? Y is not the hypotenuse. Y is the other side. So now we are looking at a different triangle. Triangle JLM. So our focus now is on triangle who? JLM. The theorem is still saying to us that the square on the hypotenuse. So in other words, 15 squared, the square on the hypotenuse. This is the hypotenuse because, as we said, the hypotenuse is always opposite the 90-degree angle, the longest side. So we say the square on the hypotenuse is equal. The square on the hypotenuse is equal to the what? The sum of the squares. Which ones? We have 12 squared and y squared. These are the other sides that we need to square. We get the sum of them. And reason, don't forget Pythagoras. Whenever we use the Pythagoras theorem, we write the reason. Please, guys, do not forget to write the reason, because failure to write the reason is an incomplete statement and reason for the triangle JLM. So 15 squared is equal to 12 squared plus y squared. But do we want y? Yes. So we need to isolate Mr. Y. He must be alone. We take 12 squared. 12 squared says, goodbye, my little y husband. I am going to work. I'm going to work. So he crosses over, catches the bus, crosses over to the other side, and then the little wifey bids farewell to the husband, and there Mrs. Little Wife is on the other side, crossing over, and 12 squared becomes negative 12 squared on the other side of the equal sign. We are left with y squared. Y squared is alone on the right hand side. As long as we isolate y, as long as we now isolate y. Guys, I'm coming back here. I don't know why you guys are failing to understand this. I don't understand. I don't understand why you guys are failing to understand. JLM. I'm going to ask you, what type of triangle is JLM? What kind of triangle is JLM? I think your comment section as well. Now, I'm going to switch off the comment section because some of you are not helping with anything in the comment section. Okay, yeah, you are not helping with anything in the comment section. Negativity is not assisting us. Yes, the type of triangle this is a right-angled triangle. Right-angled. So the theorem of Pythagoras says, okay, I appreciate those who understand. It's just a pity those who keep on saying, I'm cooked, I'm this, I'm this. You guys are, yeah, I think you guys need to go to another live or go somewhere else. You know, your negativity is not appreciated, honestly speaking. If you are having the intention of coming here to learn, then you need to have a mindset. You need to have a mindset that is one that is, okay, let's see if I can't learn something. You're going to have this mindset of I'm cooked, I'm this, I'm negativity. I'm going to switch off the comment section and I'm simply going to teach. Honestly speaking, you know, I cannot take this negativity that's here. It's not good. It's not good. You are writing tomorrow and you have this negativity. So in a right-angled triangle, guys, this is a right-angled triangle, JLM. Right-angled triangle. So in a right-angled triangle, we are told that the square on the hypotenuse. Guys, in this right-angled triangle, this box is a 90-degree angle. Opposite the box, there's always a side which is called the longest side, which we refer to as the hypotenuse. So Pythagoras theorem says the square on this hypotenuse side, there it is, 15 squared in this case, is equal to the sum here, guys, sum means plus addition. The sum of what, guys? The square on the other two sides. The other two sides we have here, guys, are 12 and y, which we don't know. So what we say is we say 12 squared plus y squared is equal to 12 squared plus y squared, and then we write our reason, Pythagoras. So 15 squared is equal to 12 squared plus y squared is the statement of Pythagoras. And the reason why we say so is Pythagoras. But here, guys, we want to solve, obviously, for this y, because we don't know what the value of y is. Unlike in this triangle, our y is not situated on the hypotenuse. Our y is actually situated at the place of the other sides. That is why it is featuring here. But to solve for y, we must isolate. In other words, we must make y to become alone. The 12 squared here needs to go over to the left-hand side. I'm definitely not going to start over. You take the 12 squared over to the other side. 12 squared, you subtract. When 12 squared goes over to the other side, you are subtracting the 12. Y is alone. If you don't know that when you take over a term, how many terms are here on the left, on the right hand side? You have 12 squared plus y squared. In algebra, you guys learned that terms are separated by a plus or a minus sign. So here on the right side, you have 1, the plus sign separates 2 terms. So if you want to isolate y, this 12 squared, you actually transpose to the other side. When you take the 12 squared over, it changes its sign from positive and it becomes negative. So that is why now on the left we have 15 squared minus 12 squared. And we have now successfully left y to be on its own with squared. Then we continue, go to our calculator. 15 squared minus 12 squared, we get 81. Okay, we get 81. 81. So y squared is equal to 81. Yeah, 15 squared is 225. 12 squared is 144. That 225 minus 144 gives us 81. So that is why, for instance, I simply use my calculator and I say 15 squared minus 12 squared. And then voila, I get that 81. But remember, guys, I need y, not y squared. So what do I do to my equation to get rid of the square? I simply take the square root. But what I do on one side, I do to the other. And when that happens, that means y becomes equal to what? Sorry, this is 81, not 18. 81, my mistake. So the square root of 81 gives me a beautiful y, which is 9. So therefore, I can say y is equal to what? 9. So that is how you find the other side when you have a right angle triangle where the hypotenuse is actually given to you. All right, guys, I'm not going to explain any further. I honestly feel like I've dealt with the theorem of Pythagoras. First, reading, together. Yes, let's not forget units, of course. Thank you so much, you're amazing. You are amazing, that's for sure. Okay, so we've looked at the theorem statement that the theorem of Pythagoras simply says in a right angled triangle. So Pythagoras only applies in a right angled triangle. And we say that the square on the hypotenuse is equal to the sum of the squares on the other two sides. That is the theorem of Pythagoras and how we are able to find missing sides in a right angled triangle. And no, I am not from Sofunda High School. I don't even know that high school. Okay, maybe people sound the same, and that is why you think this guy, that is me, is from that school. I don't even know that school. So sorry to disappoint you. Very sad. Okay, let us look at transformation geometry, because someone else indicated in the comment section, can you look at transformation, transforming? Let us look at transforming. Here we are. Let's look at this one. All right. We're gonna do all these things. Just calm down, guys. One thing at a time. All right. Let us patiently allow one thing at a time to be done. And yeah, before you know it, you'll find us there where you want it. Thank you so much, Lance Passon. Really appreciate it. The image of triangle ABC is shown on the axis system below. Do we only use Pythagoras theorem on right angle triangles, or it can be used on other shapes? Unako, like I said, the Pythagoras theorem itself is used in a right angle triangle. Remember that a shape may be there, maybe a quadrilateral. For instance, a quadrilateral like this could be there, right? It's possible to have maybe, let's say, a quadrilateral like this. Then that quadrilateral is split, and then you find that there's a 90-degree angle. And there inside that quadrilateral, there's a right angle triangle. You will use the theorem of Pythagoras for the right angle triangle situated in a quadrilateral. So wherever you find a right angle triangle, the theorem of Pythagoras can be used to find a missing side, as long as you have two sides and one missing side. So theorem of Pythagoras is only used, yes, for a right angled triangle and in no other type of triangle. Okay, the image of triangle ABC here is shown on the axis system below. Answer the questions. Guys, I will always answer questions that are important, that are asked, that are genuine. Okay, I don't know if grade 8s actually do transformation geometry, but those who are here, who have been taught, will know if they've done that or not. So answer the questions below. The first question that they ask is, they are saying, write down the coordinates of A, B, and C. K. Tandi confirms that grade 8s do transformation geometry, which is this geometry. We are on a Cartesian plane here. This is the y-axis. This is the x-axis. The y values of the x-axis here are positive. Below, they are negative. X values of the x-axis this side are negative. This side, they are positive. Okay. So now we want to know what are the coordinates of A, B, and C. Let's get a bit closer here. You can see the Cartesian plane, guys. So can you tell me what are the coordinates of A? I'm going to write them down here. What are the coordinates of A? I want the coordinates, the x and the y coordinate of A. Okay, A, in the comment section, I'm seeing people say the coordinates of A. Remember, A is this point. Okay, I'm seeing people say -4 and 3 in the majority. -4 and 3. Now let's check if that is actually true. Our x value for A is obviously this value, which is -4. That is our x value. Our y value for A is this one. You see this value? It is +3. So that means our coordinates of A are -4, because x is -4 everywhere on this vertical line. Up until even that point, x is -4. Y is +3 because y is +3 everywhere on this horizontal line. Guys, I repeat, x is -4 everywhere on this vertical line. Okay, but y is +3 everywhere on this horizontal line. Now let's move on and get the coordinates of B. What are the coordinates of B? What is the X value and what is the Y value? B Spams, I see you. Kiamochedzo, I see you as well. Ruthless, I see you. Morima, Wanga, okay, aka Blessing, I see all of you guys that have indicated, and I'm very proud to say that those who have said X is -2, Y is +2, you guys are 100% correct. X is -2 whilst Y is +2. X is -2. Y is +2. Those are the coordinates of B. Let's move on to C. What are the coordinates of C? Remember, C is here. Okay, Kanyes, I see you. Wanga, Spams, I see you. Mam Shlungwane, Lindelani Mavuso, welcome back. Badi, Zanor, Mam Shlungwane, Hlele, Ruthless, Dolly. 100% correct, guys. Thank you so much. I appreciate you. -4 and what? And 1. The corresponding Y value here is 1. Y is 1 everywhere on this horizontal line, whereas X is -4 even here, because it is that way. X is -4 everywhere on this vertical line. Okay, guys, it's so important we know how to identify coordinates from a point on the Cartesian plane. So now we know the points for each value. A, as we said, is -4 and 3. B is -2 and 2. And lastly, C is -4 and 1. That is the basic foundation to transformation geometry, being able to identify points on a Cartesian plane. Now let's move on and see if you guys will be able to help me out here as well. The image on the above grid moves or translates. Now this word, translate, 5 units to the right and 2 units up. What? 5 units to the right and 2 units up. Give the general rule for the transformation. The what? The general rule for the transformation. So they want you to write down here the general rule. X and Y, what would we say? Kanyisa, I see you there in the comment section. Thank you for your response. X and Y, what is the rule? In other words, because we're saying 5 units to the right, I will do that, and 2 units up. What is the implication on this X and Y value? What effect does 5 units to the right have, and to which variable? What effect does 2 units up have, and to which variable? Right? So Owetu, thank you so much. Murima, thank you so much. You guys are 100% spot on. So we say the rule. We write the rule in algebraic terms. 5 units up, guys, means we add 5 to who? To X. To the right means plus. Right? To the right means plus. Okay? And then we say X plus 5. X, we add 5 to it. What about Y? If we are saying 2 units up, up also means plus. So we say plus what? Plus 2. That means we add 2 to our Y value. Alright. Now guys, the words right, obviously the opposite of right is what? Is left. Let's say the question had said translated 5 units to the left. How would our rule have changed? Had we said XY? Had we said translates 5 units to the left, not 5 units to the right? We know 5 units to the right means we add 5 to X. And then we said 2 units up means we add 2 to the y. Now, what would have been the rule had we said 5 units to the left? M, I see you there. Bonte, I see you. P-spams, I see you too. Okay. So we would have done what, guys? To the left means we subtract from x. So we'd say x minus 5. And had we said, instead of 2 units up, 2 units down, how would that have affected our y coordinate? 2 units down, not 2 units up, but 2 units down. What would have been the rule? Good, Tabi, well done. Andani, good. Tyler's twin, sweet, Owetu. I see you guys there. So indeed, we'd have said y minus 2. So all I need you guys to understand is that when we write down the rule, the general rule for what? For transformation. The word translation has to do with shifting or moving something, moving the position of something. Okay? When you say left, right, it means we are moving that object horizontally. So when you say left or right, that's called horizontal translation. Okay? That's left or right. Now we understand that left means we subtract. Right means we add. Horizontal translation, left or right, that's horizontal translation. Left means we subtract from x. Right means we add to x. So we add to x, whereas with left, we subtract from x. Okay, we always know that horizontal translation will affect our x value. Then we have vertical translation. That's movement of the object up or down. Then if we say up, we know we add to y, whereas if we are moving down, we subtract from y. So guys, I hope we are clear about the word translate and how it will affect movement of objects. Okay? Next question. Write down the translated coordinates. Write down the what? The translated coordinates. So let's remember and remind ourselves that our A value was -4 and 3. B was -2 and 2. C was -4 and 1. Now they are saying, applying the rule that we have just spoken about. We had said the image moves 5 units to the right and 2 units up. Okay, and we wrote down the general rule. Now they are saying to us, write down the translated coordinates, the image of A, B, and C. Write down the what? The translated coordinates. So you guys said it best. 5 units to the right. We all said most that we are going to do what to our x's? We are going to add 5, add 5, add 5. So let's write down and look at the A. Our A value now has our A coordinate has an apostrophe. This indicates the translation by 5 units up and 2 units. 5 units to the right and 2 units up. So what will be our new x coordinates for A, B, and C? Let's first focus on x. Let's focus on x alone. So our x coordinate for A, it was -4. So what do? We add 5, we get 1. Very good. Let's go to the b coordinate. We add 5 to negative 2. What do we get for our new b value, our x value for b? We add 5 to negative 2. We get beautiful 3. We add 5 to this particular x value here. We get what? We add 5 to negative 4. What do we get for our new x value for c? We get 1 as well. So it's very nice, guys, when we first clarify the x coordinates using what we had learned about the translation of that particular point. Now we can move on to our y values. Remember, with y, we are doing what? We are adding 2. Okay? We are adding 2 to the 3. Adding 2 to the 2. Adding 1 to the 2. So if we add 2 to 3, we get 5. We add 2 to 2, we add 2 to this 2, we get what now? Thank you, OA2. C, 1D, Guija, everyone. Yes, we add 2 to the 2, we get 4. Then lastly, we add 2 to the 1. What do we get here? Hi, guys. Gina, we are just flowing here. All right. So all in all, it is now easy to get the image of A, B, and C when the A that we had, what did we say? It translates 5 units to the what? To the right, and 2 units up. And we did understand that our rule is simply this. So obviously all we are doing is we are adding 5 to all the x's, adding 2 to all the y's, and then we get our new images of the translated coordinates. Okay, make sense, guys? I will. Okay, I will. Now let's move on. It is easy. So that person was saying, transformation is making me cry. Guys, please, really and truly now. And those who are here who are saying, is this the test? Is this the test? Guys, come on now. This is a past test that was written. It's a test, for instance, that was written in a certain area on the 5th of November. So I am basically using that because some provinces have written the exams long time ago. Some kids have done with maths. They are just here watching you, laughing at you as you guys are still preparing for writing a test tomorrow, Friday, and even some of you on Monday. Okay. Let's move on to 6.2.3. Draw the translated image on the above grid with the coordinates obtained in question 6.2.2. These are the coordinates obtained in 6.2.2. What are they saying? Draw the what? The translated image on the what? On the above grid with the what? With the coordinates obtained. Where are the coordinates? Here they are. In question 6.2.2. So I'm going to go back to that sketch, remembering my coordinates for A, it was 1 and 5. So let's go and locate where X is 1, Y is 5. So here, X is 1, Y is 5. This is the new point for A, the image of A. Next up, X is 3, Y is 4. X is 3, here is X is 3, Y is 5. Let's say Y is 5 or Y is 4, or Y is 4. So X is 3, and Y is 4. Where do the two meet? They meet exactly here. X is 3 everywhere on this vertical line. Y is 4 everywhere on this horizontal line. They meet there. Then lastly, the last point, x is 1, y is 3. Where is x is 1? Here is x is 1, everywhere on this vertical line. Then y is 3, where do they meet? They meet exactly here, because y is 3 is everywhere on this horizontal line. So here are our points. We have 1, 2, 3. This diagram is the new image. B the image, C the image. And all we do is we make sure we use our pencil and we can just nicely shade it in as it has been shaded, because this is the same ABC, just that we have moved the entire diagram by how many units? 5 units to the right and 2 units up. 5 units to the right and 2 units up. This is the new image, triangle A, B, C. Okay, I hope that makes sense, guys. And I really, honestly have been, and I have explained this. I think I explained it, you know, very basically and simply. And yeah, guys, this is just that. Now I want to move on to the next question. Guys, I'm not going to repeat this, okay, because time is not really for me. If you want to watch this again, you're more than welcome to go to the YouTube channel after I'm done with the entire paper, and then you can watch it at your own time, okay? Yeah, but I hope, okay, I hope you now understand. Let's move here to 6.3. We're going to get to congruency and similarity. Just chill. You guys need to calm down. Okay, please show the formula again. What formula? What formula are you talking about? What formula are you talking about? There's no formulas here. I just wrote down the rule. Okay. Okay. YouTube link is in my bio, guys. MATHSISAGAME is the name of the YouTube channel. But the link is in my bio. If you go to my bio, you'll see grade 8 and 9 only. And then underneath that, you'll see the YouTube channel. If it does not click and lead you to the YouTube channel, copy the link, paste it on your Google search engine, and press search. You'll actually see that's where the link will send you. And I have all the live videos of the sessions that I've done in the TikTok. They are uploaded there, raw as can be, guys. They are not edited. So if you are expecting pristine, nice videos where like everything is perfect and on point, it's not. You are going to hear my same boring voice. You will hear me shout at you when you are writing nonsense on the comment section. You will basically just, yeah, you know, and the more I talk there and not teach, that's where you're going to see, hey, this repetition of things is not really helping. So that's why I'm saying go and watch whatever I did there on the YouTube channel, please. So that is the rule, x plus 5, y plus 2. Let's check this out now. Haley, you are welcome. Very welcome. Draw the image below. Let's check this out. Draw the image below in the correct position on the given axis system. Reflect. Now, this is a new form of transformation. Guys, we have just looked at what? Translation. And I just want to add this little bit of information. When we translate an object, do you know what? That object simply moves position. It does not change the shape or the size of that object. That object is the same thing, you just moved it. Like for instance, if I have my calculator here and I decide to move it like this, I want to ask you, my calculator just moved to the right. Has the calculator become bigger or smaller because I moved it? Or is the calculator still having the same size? Guys, I hope you understand that the calculator still has the same size. It did not become bigger or smaller because I moved it. It's still the same. So translation does not change the size of the object. It simply shifts the position of that object. That's all. Sometimes they ask those questions and learners, they butcher it. And they think, no, translation, it is translated, it's changing the size. No, guys, don't be crazy here. Okay, let's come here now. Now we are entering into the zone of reflection. Before I answer this question, I need you guys to just listen and take note of this particular point that I'm now going to bring to your attention here. Draw the image below in the correct position on the given axis. On the given axis system, reflect the object across the y-axis. Let's park here for a moment and unpack what terms mean. Guys, have you ever looked at yourself in the mirror? Have you ever looked at yourself in the mirror? When you look at yourself in the mirror, what do you see in the mirror? Do you see something scary? Do you see something beautiful? Do you see something worth the time, the effort? You see yourself, right? You see yourself looking at yourself. That is the beauty of the mirror. The mirror, you see yourself looking at yourself. Guys, I hope your mirror is not the type of mirror when you look into the mirror, you see the back of your head and you are looking in the other direction. Guys, hi, if that mirror is that mirror of yours at your home is doing that, I am scared of your mirror, my little. I run for the hill. Something is wrong with that household of yours. Okay, but nonetheless, the point is, a reflection is merely, it is that. Yeah, destroyer, bewitched, or something like that. When you look into the mirror, you should see yourself looking back at yourself. And so you see your image, you see yourself, right? Very important, that thing. So that is what a reflection is. So on the Cartesian plane, there are three basic reflections. At the foundation, we talk about three basic reflections. The first one is what we call reflection in the x-axis. Okay. Sometimes they like tricking you guys and they say in the line y is equal to 0. And then people are like, huh? Oh, a reflection in the x-axis and reflection in the line, they don't write in the x-axis, but then they say reflection in the line y is equal to 0. Guys, you need to understand this. You see on your Cartesian plane, this is called the x-axis, right? This is called the y-axis. The x-axis, guys, is also having an equation. Y is equal to 0. Why? Because everywhere on this horizontal line, y is equal to 0. Okay? So we have that reflection. In other words, if an object is here and it is reflecting on the line or the x-axis, then what you would see is a mirror image of that same object, same distance from the x-axis. That's why I liked somebody that said in the comment section, when you reflect something, it will be equidistant on the other side. All right? Equidistant from the other side. Equidistant on the other side. Even when you are looking at the mirror, the beauty of when you are looking into the mirror, right? It's like if, let's say, for instance, you were able to jump into the mirror and walk towards yourself, looking at yourself, the same distance that you are at from where you are standing to the mirror is the same distance that your image is on the other side to the mirror. So that's why we talk about equidistant. So if there's an object here, it lies 1, 2, 3 away from the x-axis. Then when it is reflected, it will be on this side, away from the x-axis, 1, 2, 3. I hope that makes sense. So that's why we call it a what? A reflection along the what? The x-axis. So when you reflect something along the x-axis, something beautiful happens. The y value changes, but your x value stays the same. Now, anyone who's looking at what I'm saying the object was here. It reflects on the x-axis. What's happening? Who changes? Y is going to change. Your y, maybe that was positive, changes to negative. Or if your y was negative, it changes to positive. Why? Because the y values here at the top are positive, whereas your y values here are what? Are negative. So if you are reflecting along the x-axis, y changes sign. The y value changes its sign, but the x value stays exactly the same. That's what I mean by your reflection in the x-axis. So that's what you need to just get. That, let's say you have the x and y coordinate. The minute that reflection in the x-axis changes, x stays the same, y changes sign. That's what a reflection in the x-axis does to the coordinates. It's simply y changing sign, but x staying the same. A reflection in the x-axis, or the line y is equal to 0. I hope you understand this, guys. The y value changes sign, but the x value stays the same. That's a reflection in the x-axis. The second type of reflection is reflection in the y-axis. Now think about it. If the object was this side, it simply reflects and you see it pointing or looking at itself on this side. If it was this side and all of a sudden it changes to become this side, who is changing? Who is staying the same? Who is changing? Who is staying the same? Who is changing and who is staying the same? If the object was this side, it reflects along this y-axis. It's now this side. Who has changed? Who has stayed the same? It's x that changes. Remember, guys, here on the x-axis, the x values on this side of 0 are negative. The x values on this side of 0 are positive. So in other words, when we're reflecting along the y-axis, reflection in the y-axis or the line x is equal to 0, what does that mean? The x value changes sign, but y stays the same. The x value changes sign, but y stays the same. So x, y, the change is such that x changes sign, the y value stays the same. And then lastly, the last type of reflection that they really like, which is basic, is the reflection in the line y is equal to x. Reflection in the line y is equal to x. This one is very nice because we simply swap around the x and the y. So if we have the coordinates x and y, all that simply happens is that the y and the x, they simply swap around. X becomes y, y becomes x, and that's it. Okay? We simply swap the coordinates around because the reflection is along this line y is equal to x. And the line y is equal to x, guys, is actually a line that is at an angle that passes through the what? The origin. Okay, it's a line as this, and the reflection happens along this line, which means there's a swap around in the y and the x coordinate. So these are the three types of reflection that you need to know about. So now you and I are being required to draw the image below in the correct position on the given axis system. And we are asked to reflect the object across the what? The y-axis. So immediately when they say reflection across the y-axis, I immediately move my attention to what? Point number 2. What does reflection in the y-axis mean? It means the x value changes sign, but the y value stays the same. And this is basically what it means. X will change sign, but y is going to stay absolutely the same. Now, I am going to go and see. You see where this h is? We are reflecting most across this, what? This y-axis here. From here, the y-axis, we are counting 1, 2. Okay? We are counting how many? 1, 2. So in the same way, I'm going to count 1, 2 on this side. So my new h coordinate is here. There it is. Okay? So in other words, if I could write down the actual coordinates of h, let's just be honest. This is 0. So that means this is 1, this is 2, that is 3. This is our y value that is positive. Here we have -1, -2. Okay, so the h coordinates, what are they? Okay, -2 is our x value, and then +3 is our y value. According to my reflection in the y-axis, what did we say? We said the x value changes sign. So in other words, if x here is -2, what would be the new x value for h? What would be the new x value for h? It would be +2. And guys, it makes sense. 1, 2, that's where h will be. But what about the y value? According to reflection in the y-axis, the y value stays the same. So that means we still have 3 as our y coordinate. Okay, so there it is. That is the new image of h when we are reflecting in the y-axis. X changed sign, but y, which is 3, stayed the same. Let's go to our q value. With q, we are in the same line, so we are staying in this line. Okay, q is what? -1, -2. So our x value for q is -2, whereas our y value is +1. We are on this same line, so we stay on that line because our y value is still going to be the same. But because q is -2, what is going to be the qx value for q on the reflection in the y-axis? If this x value was -2, what is going to be a q value for x this side? Okay, we have 1, 2. So that means our q value here is 2. Q, the image, is going to be 2, but the y value stays the same. It's still 1. Okay, so it's +2, guys, because the q value here was -2. We changed the sign of the x value, but our y value is still going to be 1. All right, then p. Look at p. 1, 2, 3. So here we are dealing with a -3 for p. What about the y value? 1, 2. So we are dealing with the -2 here. So we have -3 and -2. What about the p, the image of p on this side? If the x value here is -3, what is supposed to be the x value this side? A +3, because the sign changes, because we are reflecting in the y-axis, guys. Okay, so that means 1, 2, 3, 1, 2, 3. So here 3, 3, 3. We are on the same line, guys. The same line, which is -2, -2. So our P image is 3, that's positive, and still our Y value stays as -2. Then the last point that we need is that one, L. Okay. The X and the Y coordinate for L is going to be 0 and 2. L is going to be 0 and 2. Now remember, guys, since L is 0 and 2, what is going to be the image of L? Remember, who changes sign? X. But guys, can 0 change its sign? Isn't 0 a neutral number? And isn't 0 going to be, if we say it's going to be -0, I mean, obviously at the end, a negative times 0 is basically going to be 0. So what we are saying is that the image of L is still going to be at the very same place. It's not going to change. It's not going to change at all. Our Y value is still going to be 2. Our X value is still going to be 0 because 0 can neither be negative or positive. So 0 is very unique in that sense. So when we draw our image, because we were told to draw it, this is what we actually come up with at the end of the day. This is the sketch. This is the reflection of this image across the y-axis. This is staring at this across this mirror image, or this mirror. This is the mirror. This guy is staring at this one. You can see these are truly mirror images across the y-axis. That's why when we talk about reflection in the y-axis, we say x stays, changes sign, but the y value stays the same, right? And we just did that successfully, applying this understanding of reflection in the y-axis. So I'm going to hold transformation there at that particular point, and hopefully you guys have a clear understanding of that concept. Okay, right. Hopefully we do indeed. People are saying, can we do measurements? Can we do surface area? Can we do the measurements, do surface area, do measurements, do surface area? Pythagoras has already been done successfully, might I add. Okay. Let's look at a bit of surface area and volume, because you guys have been crying about that. Let's just check it out and see. So the following questions here say, calculate the volume and the total surface area of the following, correct to 1 decimal digit. Okay, Luyanda, I'm going to block you. Unfortunately, you are not someone that I need to have in this comment section. And if any of you are going to come here and use crude language, guys, I'm simply going to remove you. I'm simply going to remove you. Please don't come here and do nonsensical stuff. Yeah. Calculate the volume and total surface area of the following, correct to 1 decimal digit when necessary. volume shown is nati. Shown is nati. Do we all know how to calculate the volume of a rectangular prism? Rectangular prism. Okay. So very quickly, guys, when it comes to volume, what volume simply is the following. It is the area of your base shape times its height. In other words, how tall it is from the base shape to the congruent base shape at the top. What you should notice is that when we talk about the base shape, we are looking at that base shape that is at the bottom. Okay, so that base shape at the bottom is actually congruent. In other words, there is a similar base shape at the top that is actually there as well. So from that base shape that is similar at the bottom to the top, you talk about the height or how tall that object is. So I kind of want to do this quickly. Okay. Hopefully this kind of helps us to see the rectangular prism a bit with better eyes as well. I'm hoping you guys can see this is a rectangular prism. This is what a rectangular prism actually is. Okay. Here at the bottom, here at the bottom, where I'm shading, do you see here where I'm shading? This is what we call the base. This is the base shape of the rectangular prism that I have. What shape is at the base? Can you all tell me what the shape is that is at the base? What do we call this shape? Thank you, Owetu. It's a rectangle. It's a rectangle. So we have a rectangular base. And do you guys see that at the top, we have a similar rectangular base like we do at the bottom? Do we see that? Do we all see this rectangular shape at the top? Okay, can you see that first and foremost? Before you guys ask me about everything else, can you use the ones on the side? Can you just chill for a moment? Let's look at the object as it's standing right now. I am talking about the base. So this base at this rectangular shape at the top and this rectangular shape at the bottom, they are congruent. In other words, they fit into each other. They are exactly identical. All right. Now, how tall this actual rectangular prism is, all right, is measured from the bottom of this base to the top of the similar base. That's why I was saying the height is how tall the object is from the base shape to its congruent counterpart or congruent counterpart shape. Okay, so when I was talking to you about volume, I said volume is the area of the base. Okay. Times, please, times, it's what? How tall that particular rectangular or that particular prism is. So if we look at the space, we said it's a rectangle. My question is, what is the area formula for a rectangle? What is the area formula of one rectangle, guys? In the comment section, what is the formula for calculating the area of a rectangle? Thank you, Olo. It is length times breadth. This here, this formula represents the area of the base. But then we said when we want to calculate volume, and I want to indicate this length, this is the length, this is the breadth. L means the long side, breadth, or sometimes they refer to it as the width or breadth, okay, is the short side. Then how tall it is from the base to the top of that base, we refer to that as the what? The height. So when I calculate volume, by the way, what is volume? Volume is the space occupied by a 3D object. So this rectangular prism, if I had an actual box present, all right? For instance, this would be a typical example, all right? This is kind of like having rectangular box kind of vibes. Do you know what I mean? So the minute I remove it, the space that is open, but the minute I put it there, this thing is occupying this space. Does that make sense? This is occupying space. The space that is occupied by this object, we refer to it as the volume of the object. Okay? That's what volume is. So we calculate it by saying length times breadth, then we multiply by how tall that object is. So that's why the formula is length times breadth, because the length times breadth part refers to the area of the base, length times breadth of the one rectangle, times how tall it is, the height. Okay, I hope it makes sense, guys. You could also, like I said, place this rectangular box the other way around, okay, where you have this base and that congruent base placed in that way. You would still say the base is the rectangle that is found here at the bottom, which would also be length times breadth times how tall the height is, and ultimately it would still be the same volume answer that you would get. Volume is measured in cubic units. It's measured in cubic units. So when you write your answer, you must write cubic units. If it's units, unit cubed. If it's centimeter, centimeters cubed. If it's meters, meters cubed. In other words, we measure volume in cubic units. You must never forget that. So if we come to this again, we want to calculate the volume of this object. All right. What is this? What is that? And what is that? What is this? What is that? And what is that? So we can basically use the formula for volume and say V is equal to length times breadth times the height. So in this situation, very simply put, we say length times breadth times height, which means 7 centimeters times 3 times 8, all right? And we get an answer of what? You guys can let me know in the comment section. If you want to calculate the volume of this rectangular prism, it's length times breadth times height. We have all the 3 respective dimensions. horizontal dimension times the vertical dimension times the third dimensional dimension. So basically we get 168. Don't forget to write centimeter cubed. Thank you, Andani. We write centimeter cubed because this is volume. Very important. If we don't write centimeters cubed, then it means we do not comprehend or understand what it is we are calculating. Okay, so that's one thing. Then we have something called surface area, guys. Okay, now what's important with surface area, we need to check what are the two-dimensional shapes that make up this rectangular prism. So when it's drawn like this, you can see whatever you need to see. There is this, you see, this square, or if you want, rectangle, right, which complements this rectangle here. So there are two of these, two rectangulars that are there. They are congruent. So when we calculate surface area, we need to take into consideration what? We then check if this box, if this side is closed, these side rectangles are closed, then it means we have two rectangles. What dimensions are we talking about with these two rectangles? We are talking about the height and the what? And the breadth. So that means 2, the height times the breadth. We are talking about this area of this rectangle, but not only one of these, there's two of them. So there is one here and there's two there. So that accounts for 2 brackets h times b. But that's not all. You remember the two rectangles, the one at the bottom, the other one at the top? What dimensions are we talking about here? This length and this breadth. So we use L times B. So we are going to say 2, but then we're going to say length times breadth. We are dealing with these two rectangles, the one at the bottom, the one at the top. Then the last one, there's this rectangle at the front rectangle. You see this front rectangle, it's here, the front one, the front rectangle. Hopefully you guys can see the front rectangle. I'm just shading it there. This front rectangle, the one at the front, its dimensions, guys, is L and H, the length times the height. 2, the one at the front complemented by the one at the back. All right, so it is also H and L. So we say 2L times H. Now if you carefully look at this, there's H times B, there's L times B, and there's L times H, and these are all different. There's 2 of these plus 2 of those plus 2 of those. And as long as all of those sides are closed and solid, not open, then we know it's 2, 2, 2. And it's a matter of substitution, right? Right? So if you think about it practically, the minute you know what your L is, what your B is, and what your H is, then it's a matter of just playing around with the 3 numbers. So if you look at it, it's 8, 3, and 7. So I could randomly just say, so we have 8, we have 3, we have 7. And all you simply do, guys, is you say, if that's H and that's B, so it's 8 times 7, 2 times 8 times 7, plus L and B, 2 times 3 times 7, and then plus 2, the last ones that you have not actually made a combination of. 8 and 3 you haven't made a combination of, so it's 8 times 3. and then you simply put this in your calculator and you get your answer. And you get your answer in centimeter squared, guys. Centimeter squared. Because remember, area, the total surface area is measured in square units, not cubic. Not cubic centimeters or cubic units, but square units. Okay, square units. So yes, on my YouTube channel, there's actually a video that I once did of just surface area and volume. I did, but it's very long because I did a live lesson once upon a time on surface area and volume. Okay, so you can always check that out. Very long though, guys, because I actually start out by explaining two-dimensional area and perimeter for like your square, your circle, your rectangle, and all of those. Then I move on to this. Okay, I'm fighting for my life, trying to stay awake. Okay, so guys, do you say the calculation is 202 centimeters squared? Is that what we get ultimately? Okay, all right. That's a rectangular prism. Rectangular. Yeah, rectangular. And the way I want to really like look at it is that, like I said, you have this rectangle, that rectangle, that's 2. Remember, this one is going to be the same as this one. This one at the top is going to be the same as the one at the bottom. And then this rectangle at the side is going to be the same as that rectangle on the other side. So that's why we have 6 rectangles in total with 2. Okay, good. 3 pairs. Okay, this first pair, this second pair, and this third pair of basically rectangular two-dimensional shapes. Okay. So what that was our rectangular box. Then we have this guy. Who is this guy? Okay, I must say I was quite impressed with how I explained the triangular prism in one of my YouTube videos. There's one of the recent videos that I did it in the weekend, where I was explaining area, perimeter, surface area, and I went deep into the triangular prism. I actually even had a practical demonstration of some design, the rectangular prisms that my learners had actually made, and which I had basically used in that live session to basically explain. All right. But yeah, because there's this triangular prism, okay, and what I love in this diagram itself, it's 10 marks. It's 10 marks. Yes, I remember the formula. There's no ways that I cannot remember the formula. It's actually, I remember the formula very well. Okay, but let's start there. The volume. For the volume of a triangular prism, very straightforward, the volume, because remember, it goes back to the formulation of volume. We said volume is equal to the area. Don't forget this thing. This is helpful. The area of the base. Remember, the base will then be complemented, that base, it will be complemented by a similar triangle. Okay, since it's called a triangular prism, the base must be a triangle. Okay, so which triangle are we talking about? This triangle. This is the base. And this would be the congruent triangle. So these two, this triangle and the right triangle, these two are triangles. These are our bases. So this is complemented by that back triangle there. Does that make sense? So this is our base. So if we are calculating volume, we are saying the area of the triangular base. The area of the triangular base. What is the formula for area of a triangle? It's half base times the perpendicular height, small letter h. That is the area of the base. Since we have a triangle, the area of the triangular base is half the what? This is the base of the actual triangle. It's 40 centimeters. So we are going to say half the 40 centimeters times the what? The height. Okay. Times the perpendicular height. Which perpendicular height are we talking about? This one. This one. Do we have the length of this perpendicular height? No, we don't. Can we find the length of this perpendicular height? Yes, we can. Do we have the perpendicular height of this triangle? No, we don't. Can we find the length of this perpendicular height? Yes, we can. How? Very good, Lindeline. The theorem of Pythagoras. If this is 40, remember they're saying this is equal to that. If this is 40 centimeters, this side is equal to this side. So we need to do what to 40? Divided by 2. So that for this particular triangle, we will get the length of this triangle. So if we divide 40 by 2, why are we dividing 40 by 2, guys? It's because we've learned that the full length, which is 40 centimeters, is actually equal to the addition of 2 equal sides. All right, these are 2 from here to there and from here to there. So that means we can divide this 40 by 2 to get this length from this base to the edge of the triangle. So if we take that 40 centimeters and we divide it by 2, we get 20 centimeters. The 20 belongs for the side of the right-angled triangle. So we can come here and sort of in rough have 20 centimeters. This is 25 centimeters. And remember, this is a construction where we have a right angle. So can we calculate this perpendicular height for this right angle triangle? Yes, we can. What are we going to use? Pythagoras. 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 So when we use Pythagoras, what does Pythagoras say? It says the square, remember opposite 90, we have the hypotenuse. So the square of the hypotenuse side is equal to what? The sum of the square of the other two sides. So my perpendicular height, I'm going to square it and write the reason. Pythagoras. Then 20 squared goes over. When 20 squared goes over, it becomes negative 20 squared. I have that perpendicular height, which is squared. Grab my calculator, guys. Makes life so easy. 25 squared minus 20 squared. What do we get? 225. We take the square root of 2. We take the square root of 225. We get the answer of 50. Okay, the answer of 50. So that means our perpendicular height, 225. We take the square root on both sides, get rid of the square, we get 15 centimeters. That is the perpendicular height. Now we can go and substitute that perpendicular height for the actually what? Triangle. This triangle. the height of the specific triangle I now have, which means in my formula for the triangular prism, the area of the base can now be found. But then what do I multiply by? How tall the object is from the one base to its congruent base on the other side. Where is the height here? Where is the height? What is the height, the tallness of the triangular prism? What indicates the height? How tall the triangular prism is? What is the actual length that we are going to use for the height? Okay, I'm lost, G. So can you also do surface area of a cylinder? That's where I'm going, but you guys need to help me out. Sipomguni, thank you so much. It's Tando and Sipomguni. You guys are 100% correct. The perpendicular height here, I said to you that the capital letter H represents the height of the entire object. Just like here, the capital letter H represents how tall the actual object is. So here, the height, okay, of the entire object. Remember the triangle at the top, the triangle at the bottom, and the triangle at the top. How tall this object is actually 50 centimeters from the bottom, which is the base, to its top, the similar triangle at the top. That's height of the entire object, capital letter H. So we multiply that with 50 centimeters. Our calculator is not far from us. We just grab it and we do the things. So that is 1/2. The brackets are 40. We multiply that by 40. We then multiply that by 15. We multiply that by 50. We get what? 15,000. 15,000 what? Centimeters. Centimeters what? Cube. 15,000 centimeter cubed. That is the volume of the triangular prism. I repeat, how do we find the volume of a triangular prism? We say the area of the base of that triangular prism. Guys, the area of the base. The base is indicated by what? The triangle. Why do we know that the base is a triangle? Because the name itself says this is a what? Triangular prism. So that means the base, that base which will have a similar congruent, top, is going to be the triangle. Which triangle? This one. Why this one? Because it has the lengths that we need to calculate its area. This would be the congruent triangle at the back. So that means this is the actual capital letter H of the entire triangular prism. So we're first going to find out what is the area of the little triangle. The formula for area is half base times perpendicular height of the triangle. Not of the entire triangular prism, but of that particular triangle. We go back to the shape. Do we have the base of the triangle? Yes, we have it. It's 40 centimeters. Do we have the length of the height of the triangle? Do we have the length of the height of the triangle? No, we don't, guys. We don't have the perpendicular height here. But what can we see? We see these lines. These are characteristic lines that mean this is equal to that. Meaning, in other words, divide 40 by these two which are equal. You should get a side. This from here all the way to there. So if you divide 40 by 2, you get 20, which means from here to there is 20 centimeters, which is why I drew a little triangle there And I know that this is 20 centimeters after dividing 40, the entire length, by 2. Then for the triangle, I have 25. What is 25? It is the hypotenuse of the triangle. Why do I know that? Because the hypotenuse is always opposite what? The 90-degree angle. Always is. So if I use Pythagoras, I'm going to say the square of the hypotenuse is equal to the sum, the addition of the what? The square, 20 squared, plus perpendicular height squared, the sum of the square of the other two sides. What's the reason? Pythagoras. Then I solve for the perpendicular height. Take the 20 squared, transpose, becomes negative 20 squared. Do the mathematical calculation, calculator, we get 225. We take the square root on both sides. We get the perpendicular height is 15 centimeters. That perpendicular height is the perpendicular height for this triangle. This one, just this, the smaller base triangle, because we are on our way to finding the area of the base, which is that triangle. Okay, so as I said, in the calculator, when you transpose the 20 squared, it becomes negative. You simply grab your calculator, guys, and you say 25 squared minus 20 squared. You get what? 225. Okay, 25 squared minus 20 squared, you get 225. There it is, 225. You then take the square root. Why are you taking the square root? Because there's a square. You want to get rid of the square, so you apply the opposite operation, which is the square root. You take the square root of the square, it eliminates the square. But what you do on the left, you do where? On the right. You take the square root of 225 as well. You get 15 as the perpendicular height. 15 what? Centimeters. So that means that height for the triangle is 15 centimeters. I can now go back to the formula. We needed this height, guys. The area of the base was needing that perpendicular height, which I got through Pythagoras. So I say half base times perpendicular height times the tallness of the 3D triangular prism, which is 50 centimeters. You just multiply with that, you get this answer for volume, 15,000 centimeter cubed. That is the volume. Surface area, Z. Why are we leaving the 40 centimeters? The base of the small triangle is 40 centimeters. We used it. There it is. Base is 40 centimeters. The base of the small triangle, here it is. We used it. Times the perpendicular height. We did not have the perpendicular height. We want the perpendicular height. But this perpendicular height, which is a construction, is a part of this triangle. So we need this length from here to there. So we take this 40, since these are equal lengths, we say 40 divided by 2, we get this length, which is the same as that one. Then we use Pythagoras, 20 and 25. We take the square of the hypotenuse, 25 squared. We say it's equal to what? The sum, which means 20 squared plus the perpendicular height squared. Then we did the calculation. We got 15 centimeters for the what? For this perpendicular height. Game on. We can now find the area of the actual triangle, which is the base, by saying half base times height. We substitute. But then remember, we need to multiply all of that with how tall. To get the volume, we need to multiply that area of the base with how tall the three-dimensional shape is. which is this 50 centimeters. Where do we get the 50? It is how tall. We got the 50 there. Okay, then guys, the surface area of a triangular prism. So the 10 marks, you can see why there's 10 marks, because this is a lot of calculations. In and of itself, this could be roughly 4 or 5 marks of worth of calculation, trying to find the volume of the triangular prism. Lastly, I want to look at surface area of the triangular prism before I jump into the cylinder. I'll go to the cylinder, but I just want to look at the surface area. Guys, for a triangular prism, please look at this. We have how many triangles in a triangular prism? How many triangles in a triangular prism? Because when we calculate surface area, we need to know how many shapes do we have in this particular three-dimensional solid. Thank you. We have 2 triangles. Then we add to that, how many rectangles do we have? How many rectangles do we have? Thank you, Lifa. Jordan, Precious, thank you so much. Tiamo, thank you so much. Andani, thank you. Tyron, Sipo, thank you. Okay, guys, how many rectangles? There's 1, defined by, look at the side of the triangle. You see the side of the triangle? Length times this breadth. In other words, the height here is featuring for all rectangles. You see this rectangle? It has this side that is 50. Look at this rectangle here, this one. It also has that side 50 in it. Look at this rectangle here at the bottom. It also has this side, which is also going to be 50. So in other words, the height is consistent for all rectangles. This rectangle, the height is going to be there. This rectangle, the height is going to be there. This rectangle, for the area, the height is definitely going to be there. So when we are calculating the surface area of the triangular prism, 2 triangles means 2 half base times perpendicular height. We are calculating the area of 2 triangles. So that's why we know the area of a triangle, one of the triangles, is half base times height. Do we understand that? One triangle that we have for our object, the formula is half base times height. But the question is, how many triangles are we dealing with? Not just one, but 2 triangles, 2 areas, right, of the triangle. Plus H is common for the area of 1, 2, 3 rectangles. But all these rectangles, depending on the type of triangle you have, will have different breadths. So this rectangle, even though H, but the breadth is going to be different. For that rectangle, even though the H is going to be the same H, but the breadth is going to be different because this side of the rectangle, or in actual fact, this side and this side are the same. So the area of this rectangle and the area of that rectangle is going to be the same because of the type of triangle. This is isosceles. But this side is 40. It's very different from both. So the area of this rectangle is also going to be slightly different, but it shares the same H. So it's easy here. We just take H, we write it outside the bracket because it's common. Common for what? It's common for side length of the triangle 1, side length of the triangle 2, side length of the triangle 3. This A, B, 1, 2, 3, A, B, C represents this length, that length, and that length. Depending on the type of triangle you have, If it is isosceles, obviously two sides are going to be exactly equal, but the other third one, it's not. Okay, but remember, A, B, C. That's what this A, B, and C. It represents the side lengths of the triangle. Okay. So in other words, if you were to actually unpack this, hopefully you all understand this part. Two triangles. So it's very straightforward. It's 2 half base times the perpendicular height. But then the 2 times half means that we are going to have the base times the perpendicular height, because 2 times half gives you 1. Okay, does that make sense? Then here, the one rectangle is going to be h times a. You distribute the a to the h, you multiply. That's the area of one rectangle. Maybe it's h times this side of the triangle plus h times the other side of the triangle. So for instance, we have this side of the triangle with, for this rectangle, we have this side of the triangle, which is the breadth, and this is the length. So this rectangle, guys, will adopt this side of the triangle. I'm left with 3% energy. Feels like most of you do. And then lastly, the third side of the triangle is going to help us in calculating the area of this rectangle. But what's common is that h. So we can say plus h times c. These are all the sides of the triangle multiplied by h, because that represents one area of a rectangle, the second area of the rectangle, and the third area of the rectangle. One rectangle, two rectangle, and then three rectangle. 1, 2, 3. All three rectangles, they are individual areas. Length times breadth. The h is the length, the a is the breadth. H is the length, the b is the breadth. H is the length, the b, the c is the breadth. Nice formula here. Okay, so breadth 40 times perpendicular height. We calculated the perpendicular height. It is 15. So here, the length of the area of the two triangles is simply just 40 times 15, because that 2 and that half lead me to 1. Plus, now, let's go to the first rectangle. Let's talk about firstly this rectangle. The length is 50. The breadth for this triangle, since this is 25, that means this is also 25. So we have 50 times 25 plus, let's look at the next rectangle, this rectangle. The length is 50. The breadth is also 25. So we have 50 times 25, the second one, second rectangle. Then lastly, the third rectangle. Which rectangle is this? This bottom rectangle. What is that? It's 40 times the 50. Once again, 50 times 40. Now you can grab the calculator and put all of this in. You should be able to get the answer, guys. Okay, very nicely. Very nicely. So this is basically what I'm saying, right? What I've done here is helped you understand how the surface area formula is formed. Two triangles means the area of one triangle, half base times height. But if you have two, you are saying 2 times the half. But remember, 2 times half is simply 1. Okay, so you have b times h. Slowly shutting down. That's fine. Then here, you have 3 sides of the triangle. Remember, I said 1, 2, 3. Each side will actually take care of a rectangle whose height is the length, which is the same for all the rectangles. That's why we have h on the outside, it's 50. Then each side of the triangle represented by A, by B, and by C. Then all you do, h times A, one rectangle. H times B, the second rectangle. H times C, the third rectangle. You multiply, you add everything together. So Precious Chamala is saying the answer is 4,900 centimeter cubed. Precious Chamala, remember, area is not measured in cubic units. Area is measured in square units. Okay, Jordan is saying 3,850. You guys are having different answers. So let me check with my calculator, just in case people are misleading me, because it is at night. 40 times 15. Let's put the brackets nicely there so that our brackets can help us out. We add another bracket. 50 times 25. We close the bracket. We add another bracket. 50 times 25. We close. We add another bracket. 50 times 40. We close. We say equal. We get that answer. You guys are getting different answers there. I'm getting 5,100. You guys are getting 75,300. Are you kidding me? Now that's where the marks are lost with the calculation, right? There is it, centimeter squared. Centimeter squared, guys. Okay, so I've calculated volume of a triangular prism, and then I've calculated area, and I've tried to explain as best as I possibly could, right, how we go about doing that. Now the cylinder. Let's check the cylinder. Cylinder is like Somos. Okay. Let's say we had the height 50 centimeters, and then let's say we had a radius of 5 centimeters. Okay. Yeah. Then we want to calculate the what? The volume. And then after that, the surface area. So let's start with the volume. Okay. Yes, this is one more, and I think this will be my last one, because, yeah, let's hold it right there. I'm done myself. If I go on any further, I'm just going to also not be as effective. Okay. So our height is 50 centimeters. How tall? Remember, with a cylinder, it is also a prism, because at the top we have a circle, at the bottom we have a circle, and basically this is the situation we are talking about. Circle, circle. Okay. So when we talk about volume, we are still talking about the area of the base times the height, how tall the object is. We're saying the area of what? The base. So the question is, since it's a cylinder, the base is a what? Is a circle. There's one at the bottom, there's one at the top. Okay? Did you see, guys, this thing? So with the rectangular box, the area of the base is a rectangle. There's one at the top, there's one at the bottom. You know? Triangular prism. With the triangular prism we had just looked at, when we're looking at the volume, we are talking about the area of the base times how tall the three-dimensional object is. So there's a triangle at the bottom, there's one at the top. With the cylinder, there's a circle at the bottom, there's one at the top. And those two circles, bottom and top, are congruent. So the area of the base means the area of the circle. Does that make sense, guys? And those who are, just for those who are possibly, let me just say this. There are people who I'm seeing in the comment section, they are saying they'll be writing GEC multiple choice. Very kindly and nicely. If you go to my YouTube channel, guys, YouTube channel is popping there. I have a playlist there for grade 9 GEC 2022 past paper, right? In that past paper, there were actually some videos that I did. If you go to the grade 9 GEC part, the paper 2 part, there are 10 videos in this playlist. Okay, how many videos? 10. Okay, and in those 10 videos, guys, okay, in those 10 videos, I plead with you, go and check out from part 6, I believe, part 6, part 7, part 8, part 9, and part 10 of those videos. Part 6 is where I start with the geometry. In factual fact, this GEC paper in 2022 was both a paper 1 and a paper 2 in one paper. So part 1 to 5 is not going to really be beneficial to you because it's the paper 1 stuff. You guys have already written that. But for part 6, 7, 8, 9, and 10 of these videos, it covers all the geometry. I would advise you to go and check out the aspects. It is also multiple choice. So yes, I do the working outs on the side, and then I look at the options and we select the right options. Okay, so please, when you have time, I know you guys are writing GEC only on Friday, right? Today is Tuesday. Very soon, in a few minutes, it's going to be Wednesday. So yeah, prepare adequately. Use the grade 9 GEC 2022 past paper playlist from part 6 onwards, and please check it out. It will help you a lot. I'm telling you. There it is. I just highlighted there. If you see on the screen, grade 9 Maths GEC 2022, question 40 to 45. I think that's where the grade 9 paper 2 GEC part starts. From part 6, part 7, part 8, part 9, right? And then there at the bottom, I actually have the grade 9 Maths paper 2 GEC with explanations, which is a video that purely focuses on that. Okay, thank you for the revision. I'm done writing and I ate paper 2. Very good. I'm glad for you. No, I'm glad, guys, if you are eating the papers. That's what's key. Thank you for that feedback. Really appreciate it. It is much appreciated. Lotting, very much. Good stuff. Good work. Keep it up. Okay. Yeah. Because I'm seeing the comment section and I'm seeing people are talking about GEC galore. Please, can we continue? Neurosurgery is always on a continue. Please, can we continue? Please, can we continue? Please, can we continue? Please, can we continue? Okay, so cylinder, guys. Area of base times height. Since it's a circle, we know that the area of a circle is pi r squared. Pi r squared. So the area of the base is going to be pi r squared, because the area of a circle is, the formula that we use is pi r squared. Okay, r means the radius. Remember, if ever you are given the entire diameter, you divide that diameter by half, you get the radius, and you can always substitute it. Then we multiply that with the what? With the height, how tall the object is. Okay, and guys, please always make sure that when you do calculations, always check that the SI units, okay, are the same. But if you find that they are not, always remember this conversion here. If you want to convert kilometers to meters, you times by 1,000. Meters to centimeters, you times by 100. Centimeters to millimeters, you times by 10. Vice versa. If you want to convert millimeters to centimeters, you divide by 10. Centimeters to meters, you divide by 100. And then meters to kilometers, you divide by 1,000. Okay? Yeah, it makes sense, ne? Yeah, we do those things. Tired. I need a breather. Candy, didn't you end the live? Look at this. What is this? Oh, maps having the answers there does not always mean that things are better, eh? It doesn't mean things are better. Because if you don't understand your work, you're going to be selecting all the wrong answers. Okay, so yeah, just make sure that you understand. So here, very simple then. Pi r squared, you will just take our calculator. Pi r, we know is 5, so 5 squared. Then we multiply that by height, which is how tall, that 50. Okay, and then you can substitute that, you get your answer. Precious Chamalala, you need me as a teacher. That's why I'm here, Mozi. What more do you need, right? Hopefully you guys can be part of my early preparation. Thank you, Bohang, for the rose. You guys can be part of my early preparation group or crew in the holidays, right? I know you guys, some of you are just burnt out from studying and school, and you just want to put books behind and put them away. You don't want anything to do with school anymore, But let me say, guys, those who are interested, I'm actually wanting to explore a path with a group of special students. If you don't regard yourself as special, then fine, chill, enjoy your holidays and have fun. But if you regard yourself as special, it could be nice for you to hop on to my early preparation session. Okay, it would be nice for you to hop on to my early preparation sessions that I'm intending to host this coming weekend up until the end of the week, next week on Thursday, So starting this weekend on Saturday all the way to next week Thursday, I'll be hosting an early preparation session type for preparing learners that are in grade 9 for grade 10 next year. We go down and we do the basics so that we can prepare any learner for grade 10 that's coming up. Then on the 15th of December, I will come back and continue that session. No, guys, I'm not going to do it in January. I'm not subscribing to your timeline. Like I said I need just a special group. If it's 2 learners, doesn't matter. I don't need all of you guys. I just need the ones that want. I need only the ones that want. I don't need everyone. The ones that want, and they want to not play around with maths, and they want to just have a distinction time next year. I want those people. I don't want everyone. I don't want negative people hear me. I just need the people that think they need this thing. So there will be a special fee attached to that, which means you are going to have to go and tell your parents about it. Go tell your parents about it. I'm going to post the details, and I'm going to send some of you, because those who join my live sessions, I know some of you. So, I get the summary of who joined my live. I will send you guys private messages and I will let you know that, hey, so-and-so, I saw you in my live. Would you be interested in this? Here are the details. Forward this message to your parent. Check if your parent is fine with this, and if they are willing to subscribe to actually this certain fee or amount. And then this is how things are going to be. Like I said, we're going to run from this weekend to next week, Thursday. Then we are going to take a break. I am going to go marking from the 30th up until the 12th, I think, of December. Then I'll come back. On the 15th, we are going to restart, 15th of December, until the end of the year. We are going to continue with what we started this coming weekend. Then, like I said, there's that special fee, which will accommodate the entire thing. So please just let your parents know something like this is on the horizon, and then we can basically deal and see how we go about it. Otherwise, all in all, those people who are saying, I wish you were my teacher, maybe this is your chance. We can get things rolling so that when you go back to school, come next term, you will not be saying things are chai. You will not be saying you are cooked. You will be saying, I am cooking 8 dijo munati, those things. So anyways, let me just continue. Okay, so guys, hopefully you put this in your calculator. You got the answer. All right, what answers did you get, guys? Yes, Nkanyane, next year I'll definitely be doing those. I'll be doing science as well, next year. Bit of preparation underway with that. Did you all get this, guys? Is this correct? Clock it, Menier. Yes. Is it pi 5 squared times 50? Do we get 3,926,99 centimeters squared? Is that the answer that we got? Precious is saying yes. How do we do it? The answer. Hey, guys. How do we do it? Hey, bud. They're saying no. Some are saying yes. Grab the calculator. Let's grab it. Grab it. Pi. Gidding. Pi. Shift. Pi. Yellow. Pi. Times. R. 5 squared times 50 equal 1,250 pi SD. There it is. So 100. Lesser. Don't like your language. You need to mind it. I don't want to hear that. That one, don't want to hear it. Kalok, we want the decimal. Okay. Decimal helps us with getting decimal. They say round off your answer to 2 decimal places. You better make sure that it's in decimals. So that's why we press SD. Okay, we don't want our answer in terms of pi. We want our answer in decimals. Okay. So that's the volume. That's how we calculate volume. Our formula for volume for a cylinder: pi r squared times height. Why pi r squared? The circle. Y times h. H means how tall the 3D object is. So we substitute that. We get the answer, centimeter squared. We all together, people? I think so far we are. Let's move on. Let me write now the last thing. Surface area. How do we calculate the very same cylinder? How do we calculate the surface area of a cylinder? That's the $1 million question. Not like 2 or 3 examples, guys. Not like 2 or 3. Me, I just want to at least give you an idea. Okay, give you an idea. So you want congruency and similarity. Okay, I'll quickly do congruency and similarity after this. Crazy Han Matilda. Okay, the crazy Han. The craziest Han. Okay, here we are. Total surface area is equal. Now, remember, with a cylinder, we have how many circles? There's the top circle, and there is the bottom circle. That means how many pi r squares? 2 of them. How many pi r squares, guys? 2 of them. Then the following requires me to do a demonstration. Guys, if we pretend that what we have here is a cylinder, this guy, this one, okay? Remember, this would be our bottom circle, this would be our top circle. I'm sorry guys that you know, but I hope you get the point, okay? Right? Yeah, if this is our cylinder, this is the bottom, top, because this is the cylinder, right? But if we were to open up that cylinder, neurosurgery is asking what is a cylinder. Imagine a Coke can, you know, imagine a Coke can. That's what a cylinder is, right? It's like even something like this, all right? Imagine that what you see here at the bottom is the same thing that you see here at the top. So in other words, a cylinder is something like this, right? But if you were to imagine that this here, this circle here at the bottom, let's say you had a congruent and similar circle here at the top, this is what we would refer to as a cylinder. So this is something that's an example. I'm not saying this is a cylinder, but this is the example that I can give you, okay, of what a cylinder is. Now guys, what you can see here, sour worms, guys, love this. This is life. This is life. I'm just kidding. Okay, so anyways, so cylinder, this is mistake. Cylinder, circle at the bottom, similar circle at the top. All right, so if I was to cut this, let's say I cut this, okay, let's say I cut this and I opened it up, right? If I would cut this and open it, this is what you would see. You would see a rectangular shape. A rectangular shape, all right? That's what you would see. So in other words, the height of your cylinder would be represented by the length of this rectangular shape, okay? I hope that makes sense. Okay, so if I was to cut this here, cut it, and then open it, what you would see is a rectangular shape like this, okay? This would definitely be rectangular, like this, right? So they have this. They say the formula for a cylinder, okay, is 2 pi r squared plus 2 pi r h. 2 pi r squared, that means the two circles. But then they say 2 pi r h, okay, 2 pi r h. I repeat, 2 pi r squared plus 2 pi r h. So more specifically, this is 2 pi r. So what I substitute here is this 5. Here, the radius of the circle, plus 2 pi. In the place of r, I substitute the 5. Okay, total surface area, or surface area if you want. Okay, I just wrote TSA for total surface area. The h is the height, how tall the object is. So 2 pi r is 2 pi times 5, so it's just 2 pi, and then I write the 5 centimeters there. Then the h is the 50. Okay. It's just a pity that I'm holding one of my hands with my phone, because I would have wanted to explain where this comes from, but it's very difficult for me to do so with one of my hands holding onto the phone. So I'm going to try to actually do something, which means I'm going to try and do a video of explaining how this part 2 pi rh comes about, you know. But the short of the long is that when you basically, let me just say I'm going to explain it at another time so that you guys can have clarity about it. But what's important is to know that this is the formula. 2 pi r squared, meaning the two circles. And then lastly, 2 pi r h is to explain, you see, because you know the area of the two circles, this circle and that circle, and that represents 2 pi r squared. This 2 pi r h represents the area of, you see where I'm holding my hands, where my hands are holding, that is the area of the circular part of your cylinder. So this circular part is represented by the formula 2 pi rh. Okay, so 2 pi rh represents the formula for the area of this part that my hands are around. You see where my hands are holding? This is the circular part of the cylinder. It is represented by the formula 2 pi rh, and it has an explanation, but it's very difficult for me to try and explain whilst I'm holding my phone with the other hand. Hence I'm saying I will try and do a special video to kind of like unpack for you what I mean by this 2 pi rh and where it comes from, so that you guys can have a clear understanding of what it means. All right, but for now, what's important is to just understand that the formula for the surface area of a cylinder is that you have two circles, so that's 2 pi r squared, and then this 2 pi rh represents the area of the circular part of that particular circle, which is 2 pi rh. So all you do is you write the 2 multiplied by the pi multiplied by r, which is the radius of the cylinder, and then the 50, which is the height, and that's how you are basically able to get the answer. Formula for the volume of a cylinder is pi r squared. Remember the area of the base. What is the base of the cylinder? It is a circle. What is the area of a single circle? Pi r squared. So that's the area of the circular base. It's pi r squared. Then we multiply the area of the base with the height, how tall the cylinder is. So that is h, which is 50. So that's the area formula for the volume of the cylinder. And remember guys, sorry, I forgot to write here, it's not squared but it's cubed, because volume is in cubic centimeters, not centimeters squared. So we write cubic centimeters. Lastly, here you would basically grab a calculator so that we can calculate the surface area. So we have 2 times shift pi, we times that by 5 squared, we add 2 times, we multiply by shift pi, we multiply by 5, and we multiply that by 50, which gives us a beautiful answer of 550 pi, but then we press ST. We get 1727.88 centimeter squared. This is the surface area of the cylinder if we were to actually get it in that fashion. Okay. Now, I think I will be doing an extra overload right now, but since people are insisting, let's quickly check congruency and similarity. One more. Kish, thank you so much for the rose. Guys are very kind, I must say. Some of you are very kind. Okay, circumference of a circle, guys. If you want the circumference, remember there's perimeter and area. So if you are looking at the circle, if you want to calculate the distance around the circle, we call that the circumference. And the circumference is simply 2 pi r. That is the circumference of a circle. 2 pi r. The circumference of the circle is 2 pi r. That's what it is. Okay. Crazy Han, a quadrilateral. If you want to calculate the perimeter of a quadrilateral, how many sides does a quadrilateral have? Let me ask you. How many sides does a quadrilateral have? Let's just say any quadrilateral. R stands for radius, yes. R is radius. Yes, Morendo. Quadrilateral has 4 sides. So what do you do when you are calculating the perimeter of a 4-sided shape? You simply add all 4 sides. Remember, perimeter has to do with the total distance around a shape. So if it's a 4-sided shape, you just need to make sure that all 4 sides are represented so that you add all 4 sides of that particular 4-sided shape. Perimeter means total distance around an object, around a 2D shape. Okay, hopefully you understand that. That's what perimeter is, total distance around a 2D shape. Yeah, walking around, you start from here, you walk. Okay, you measure from here to there, you walk. From here to there, you walk. From there back to where you started. That is perimeter, you know. So you would measure. If it's 5 centimeters here, it's 12 here, it's 3 here, it's 2 here. You add all of those 4 sides together, you get the perimeter. Okay, hopefully it makes sense, guys. Okay. Yeah. Okay, here. Come here, congruence. In the diagram below, prove that triangle KLM, here, these 3 lines, what do these 3 lines mean? Congruent. Okay. Congruent. KLM, here is KLM, this triangle. Prove that it is congruent to triangle KNM. So where do we start? Look at KL, you see this line. Look at KN, you see this line. What do these 2 things mean? KN and KL, they are what? What does this line and this line mean for these 2 sides? It means KN is equal to KL. KN is equal to KL because of these lines. It means equal. What's the reason? They are given. That is given to us. So we write Kn is equal to Kl. That's given. What is that? That's one pair of sides that are equal. So I write S just so that for me I can see, okay, what case is being developed by what evidence I'm showing. What else is there? Lm, which is that, is equal to who? To Nm. Why are we saying that? Two lines, two lines. That means what? Those two are equal. What's the reason? No, that doesn't mean parallel, guys. When you have lines like this, that means equal, not parallel. Lm is parallel to Nm. That is another pair of sides that are equal. So I have my second S, a second pair. Okay. Then, as you guys are saying in the comment section, Junaid, Lato, and Precious Chamal, they are saying Km for this triangle is equal to Km or Mk for this triangle. Km is equal to Mk. Km for this triangle is equal to Mk for this bottom triangle. What is that? Common side. The two sides are common. This is a common side for both triangles. That is our third S. So that means we can conclude that triangle. Now you look at the order that you have there. Triangle KLM is congruent to triangle KNM. What is the case of congruence? S, S, S. Side 1, side 2, side 3. This SSS means side, side, side. This is a case of congruence because the three pairs of sides are equal for these two triangles. We say that these triangles are congruent. Okay? And we are able to get 1 mark when the statement and the reason are there, 1 mark when the statement and the reason are there, another mark when the statement and reason are there. Then our conclusion of triangles congruent with the case there, we get the 4th mark. So that is 4 beautiful marks that we get for proving that the two triangles are congruent. Okay. Guys, SSS is one case of congruence. There are 3 other cases of congruence. One is side, angle, side. SAS. One pair, one angle, another pair of sides. If you can prove that a side and an angle and a side, it's important that for this case, the angle is sandwiched in between two sides that are equal. The angle is sandwiched in between the two sides. The angle must be in between, guys. Not on the side, but in between. So it's not SSA. No, that's wrong. It is not ASS. No. It is side, one pair of sides, angle in the between the two sides. Angle equal to that angle, the side equal to that side. Now that is true SAS. Okay? Right? Please, very important. So that's the second case. We know the first case, that is the second case. Then the other case we have is angle, angle, side. Okay? Or sometimes referred to side, angle, angle. Okay? Then the last one, right-angled, hypotenuse, side. Right-angled, hypotenuse, side. That is the third case of congruence that we can expect and anticipate to get in any given situation. Okay. So for instance, check this out. ABCD is a parallelogram. Prove that ABD and BCD are what? Are congruent. ABCD is a parallelogram. We need to prove that ABD and BCD are congruent. How do we do that? So what do you guys see? This statement is very powerful. ABCD is a parallelogram. What's my first statement and reason that I can write down that is correct and true? Let's hear you guys. Don't write the case. What first statement? This is 4 marks. So we need to actually show this is equal to that and why. So Junaid Latour is saying AB is equal to DC. AB is equal to DC. Guys, we can't say AB is parallel to DC. To say AB is parallel to DC is not going to help with anything. Parallel sides do not move us towards congruency, but equal sides do. So if we say AB is equal to DC, remember what were we told? We were told that ABCD is a what? Is a parallelogram. So that therefore means AB is equal to DC. We know that the opposite sides of a parallelogram are equal. Okay, so AB is equal to DC. I just write opposite sides of parallelogram. This is a small symbol, okay, for parallelogram. Okay, so opposite sides of a parallelogram. What else is people saying here? Okay, AD is equal to BC. Okay, I see someone saying that AD is equal to BC. AD is equal to BC. Why are we saying that? AD is equal to BC. Reason? Op sides of a parallelogram as well. So we have an S, we have an S. Okay. Someone else could say angle A is equal to angle C. Angle A is equal to angle C. Why do we say that? Remember, we were told that ABCD is a palm. What do we know about the opposite angles of a parallelogram? Opposite angles of a parallelogram. We know that the opposite angles are equal. So what did we just discover? This side is equal to that side. That side is equal to that side. And lastly, this angle is equal to that angle. So what are we seeing here? A side, 2 sides, and 1 angle. But remember, guys, we need to write that case of congruency in the order that it is correct. So if we write SSA, that's not correct. Okay, so we are going to say triangle ABD is congruent to triangle BCD. But be careful when we write our reason. Side, angle, side. The 2 sides in between that angle is there. The 2 sides in between that angle is there. So we write side, angle, side. We don't write SSA. We write side, angle, side, because this only is the only way in which this case is written. It's not written in any other order, but side, angle, side. So this is a case of congruency we could have used to prove that these 2 triangles are congruent. In as much as someone else could have said this side is equal to that side, S, this side is equal to that side, S, and then said BD is common. That would have also been a wonderful way to say ABD is congruent to BCD and then write SSS, not SAS, but SSS, because you would have proved this was equal to that, that is equal to that, for these reasons, of course, and then said BD is common. All right, BD is equal to DB, common side, and then you had said that triangles are congruent for side, side, side. Okay. So there are various ways, guys, okay, that we can actually answer questions related to congruency. Okay. Puseledzo, definitely not going back to transformation, because I did transformation okay, it would really be taxing on me to go back and do something that I had already done. Okay, definitely taxing for me. Okay, yeah, definitely don't forget to pray. Very important aspect of your mathematical journey. PQRS is a kite. PQRS is a kite. Looking at quadrilaterals, find the sides A and B. Okay, don't forget the reasons. To simply just write the answers, but the reasons are not there. Okay, now I'm gonna go do similarity just now. So yes, A is equal to what? 4 centimeters. Why? Adjacent sides, or sides of a kite, you could say. Okay, adjacent sides. A is equal to 4 centimeters. What's the reason? Adjacent sides. Adjacent means the sides next to each other. Adjacent sides of a kite, or you could say sides of a kite. We know that the sides of a kite, a pair of adjacent sides are equal in a kite. So if this is 4 centimeters, A is also 4 centimeters, adjacent sides of a kite. They want B as well. Where is B? There is B. You guys said B is equal to 9 centimeters. Don't forget adjacent sides of a kite. The reasoning is important whenever we're using special properties in the quadrilaterals to basically answer the question. Okay, I'm doing page part 2, Munyata. I'm not doing paper 1. You want me to do grade and an intercept of a graph. I'm doing paper 2. But I'd really advise you, last night, okay, or let me say in previous live lessons I've done such. You can go and check out my paper 1 grade 9 on my YouTube channel. You can go check out the grade 9 paper 1 videos. Okay, especially the GEC videos that I did. A lot of straight line, linear functions, graphs, and explanations on those things. All right. Unless you can drop me a galaxy here, then I'll be happy to do that. I'll abandon everyone and just do what you want me to do. But unfortunately, galaxy, sorry, my few hours left. All right. Then here, guys, we have 80, we have 50. Thank you, Screw F. I really appreciate Screw F saying appreciate the work. I really appreciate it. 80 plus 50 plus x plus 70. 80 plus 50 plus x plus 70, guys, we want to get the value of x. Very good, Tsiamo. Oh, Bohlale is like feeling the pressure there. I could see the tears there, Bohlale. Thank you for the finger heart. It's like, Bohlale, I could probably sell my soul to the highest bidder. So, Bohlale, what do you want me to do? It's between maths and life. My goodness. Okay, here we are. X plus 50 plus 80 plus 70. You guys said it correctly. We definitely are going to say that. X plus 50 plus 70 plus 80. We are going to say that's equal to 360 degrees. And the reason why we say that is because we know that this is the sum of angles in a quad. Sum of angles in a quadrilateral, guys, give us 360. We have 4 of the angles. 80 plus 70 plus x plus 50. We say it is equal to 60 degrees. Reason, sum of angles in a quad. The interior angles of a quadrilateral add up to 360. Yes, guys. So all quads, basically, any quadrilateral, 1, 2, 3, 4-sided shape, has all angles adding up to what? To 360. Very key. All right, are we together? I love that. Then we can solve for x because we can. We take that 50, we subtract. That's positive. We subtract that 70, we subtract that 80. And we take our calculator if we don't know what else better to do. But people are saying the answer is 160 degrees, and I believe them. Okay. Thank you, guys. Crazy Han Matilda, thank you. Siamo, awesome. Yes. 160 degrees, guys. 3 marks in the bag. Not a problem. Not an issue. Okay. Let's see. ABC and triangle ABC and triangle XYZ are congruent. Show with reasons why this statement is correct. Show with reasons why this statement is correct. They are saying ABC and XYZ are congruent. You're welcome, Kiandra. Okay. Hopefully the galaxy, I can see the galaxy globe that girl is dancing next to. It's coming. So hopefully it will come, Kiandra. Triangle ABC and XYZ and triangle XYZ are congruent. Show with reasons why this statement. I now confer all my knowledge to you, Tyron. Receive it in your head, in your fingers, in your toes. Receive it now. Receive it all my knowledge. Receive it now, Tyron. Triangle ABC and triangle XYZ are congruent. Show with reasons why this statement is correct. So, always say AB is equal to XY, which is equal to 2 centimeters. We can see that AB is equal to XY, which is equal to 2 centimeters. We are both equal to 2 centimeters. That is given to us, guys. We are showing with reasons why the statement that is there is true. This is one of them. Lastly, angle A is equal to what? Is equal to angle Y, which is equal to what? Both of them. Angle A is equal to angle Y. They are both equal to 29 degrees. Thank you so much for the rose. Reason, it's given to us, this thing. Thank you, guys. Really appreciate it. So we have S, we have A. What else is there? AC is equal to what? ZY, which is equal to what? 3 centimeters. Y, it is given to us. Thank you, Kiandra. 2 of those roses. Really appreciate it. It's S. It's given to us. These are given things. So does that then make sense that triangle ABC truly is congruent to triangle XYZ for the sole purpose and reason of side, angle, side? That's why. So when they ask us, are these congruent? Well, they are saying they are congruent. Show with reasons. There, we've shown with reason, shown with reason, shown with reasons. Indeed, the triangles are congruent. Thank you so much, guys, for the roses. You're really generous after 12. I would say that whoever is praying after 12, I think the blessings have located me right now. I receive them all. I receive them all. I receive all the roses. I receive them all. Thank you. Thank you, Jesus. Yeah, like I said, I transfer all brain activity and brain sweetness and goodness unto all of you. Receive it now. Receive it now. You know, I can just see myself being that pastor who's just like, receive it, receive it. And you're like, I receive, amen, amen, I receive. Yeah, guys, let us come here. Even our sins. My goodness, guys. You guys want forgiveness of sins as well. Okay, here is the thing. In diagram below, AB is parallel to PQ. Here is AB. Here is PQ. Right? Prove that triangle ABO. Now here is that symbol. Similar. Congruent has 3 horizontal lines like this. That's what congruent means. And there are 4 cases of congruence, as we have said and indicated. But now here we are being asked to prove that triangle ABO is similar to triangle PQO. Listen to me and listen to me well. Similarity can be proven in one of two ways. The first way is if we can prove using this case, which is also called angle, angle, angle. This, in English terms, is equiangular. All right? All right. So if you can prove three pairs of equal angles, guys, for the two triangles that you have, then you simply can conclude that the triangles are similar for this reason. Okay, so similarity can be proven using equiangular. Three pairs of corresponding angles are equal. That proves similarity of triangles. If not, the second way to prove similarity is to basically look at proportional sides. Proportional sides. Sides in the same ratio. Okay, right? But in order to use proportional sides, you must have all sides for both triangles. You must have all numerical sides for your triangles. You must have all numerical sides for both of your triangles. If you don't have, guys, the numerical sides for your triangles, then don't bother yourself going down the rabbit hole of proportional sides. You only go to the rabbit hole of corresponding sides are in proportion if you have all the numerical sides of your triangle. Then you can go down that rabbit hole. So let us check for this scenario. For instance, what can we use to prove that the triangles ABO is similar to triangle PQO? Let's check. Firstly, let's say I wanted to check, can I prove sides in proportion to prove similarity? What do I first check? Triangle ABO, does it have all the sides? Let's check. ABO, do we have all the sides of triangle ABO? Let me ask you guys, do we have all the sides, the numerical sides of the triangle? Do we have the numerical, meaning in other words, do you have numbers for each side of the triangle for triangle ABO? Junaid is saying yes. Scheme Carlo is saying yes. Kamokhelo Kotol is saying yes. Crazy Han is saying yes. Tandy is saying yes. Ogamo is saying yes. Tiamo is saying yes. Tomi is saying yes. Katlo is saying yes. Yes, yes, yes. Oshal is saying yes. Okay, we do here. Let's move on to triangle PQO. Do we have all the side lengths of triangle PQO? Do we have the numerical values? Here is POQ or PQO. Do we have all the sides? We have 12 here. We have X there. We have nothing there. Do we have all the sides? No. So Mr. You and me, Mrs. You and me, Maths is the game people like you and I don't play. We don't choose the game option of proportional sides as Maths gamers because we can see that we don't have all the numerical sides of the triangle. So trying to prove similarity using corresponding proportional sides is not going to work. So when we come, we are like, not you, sir. So that means we are going to go down this rabbit hole. Equiangular is what we are going to look to. Now, can I tell you something, guys? Something very beautiful. Okay. Guys, don't even think about doubling and all of that stuff, guys. we are asked here to prove that triangle ABO is similar to triangle PQO. Don't even think of doubling and all of that stuff to get the missing sides. You can't do that because we don't know if the triangles are similar, and we can't use proportional sides to prove that the triangles are similar because, as I said to you, you do not have all the sides of the triangle given to you. So don't go down that rabbit hole. Don't go down that rabbit hole. Don't do it. Don't do it. Don't go down that rabbit hole. You're going to cry. You're going to cry. Okay? Let's come here. Let's come here. We are going to go down the equiangular rabbit hole. It is the hole that will give us pure joy. So, ABO. All I need to do is say this angle is equal to that one. Hey, first is equal to first. Angle A is equal to angle P. I just need to find a reason. Let's go. First is equal to first, second is equal to second, third is equal to third. Let's check. Angle A is equal to angle P. What is the reason, guys? Angle A is equal to angle P. Just give me a reason. Quickly, guys. I need a reason. Quickly. Just a reason. I want to see how good you are, guys. You are making me cry in the comment section because you're not giving me the reason I want. You are not giving it to me the way I've been explaining for the past few days. You guys are just saying alt angles, and I'm not happy. I'm very sad. You guys are making me cry. Yeah. You guys are crying, making me cry. Yo, I am crying now. I'm crying. Alt angles is not enough, guys. Thank you. Who is this person? Dischased. Who is this? Dischased Pomawawa. Yo, this guy has a crazy name. Dischased Pomeranian. Yeah. Some people have names for days here. Thank you, Scroof. Thank you, Sechofat. Guys, please, man. By now, you should get my mojo. Alt angles. Yes. Z shape, right? Z. This angle is equal to that angle, but we must also include the lines that are parallel. There's no power if you don't include the lines that are parallel. Okay, please, guys. Angle A is equal to angle P. First is equal to first. Let's move on to the next one. Angle B is equal to angle Q. Let's just come with a reason. Yeah, Pomeranian received my blessing of my brain. Very good for you. And all the other people that commented nicely afterwards. You have received. You guys did not just receive for no reason. You received for sure. We want to now say angle B is equal to angle Q. What is the reason, guys? What is the reason? B is equal to Q. How did? Thank you, Khotli. You see now, you are coming there, guys. Same reason. Angle B is equal to angle Q for the same reason. Alt angles. AB is parallel to QP. Please, guys, don't disappoint me tomorrow and start writing reasons that don't have parallel lines when you are using these things. If you just write alt angles, guys, not enough. Take it to grade 10 and you will thrive if you guys will be part of my building up the learners for grade 10 for next year. You'll be thriving. You won't just make it, you will thrive. Okay, last one. This angle O is equal to that angle O. Which angle O, guys? Angle BOA. Now we need to be very specific there. Angle BOA is equal to what? To angle POQ. Angle POQ. What is the reason, guys? Please, guys, you can't just say angle O is equal to angle. No, you must specify angle BOA, or you can say angle AOB, the middle letter with the cap on it. The cap on top of the middle letter represents the angle you are talking about. Thank you, Rizin. Hey, I love you guys. Hey, I love guys. I feel like I'm falling in love, very deep in love here with these kids. These kids are doing the things, they are writing the things that I love. Okay, please, guys, please. No, angle O is not common. Don't say that. Kamukelo, angle O is not common. Angle BOA is a different angle from angle POQ. It's not a common angle. It is an angle that is vertically opposite to the other, which makes the angles equal. Don't say common angles. They are not common. When something is common, it means it's the same angle. These are not the same angle. They are equal, but different, but equal. Please, guys. Yeah. Our first A, our second A, our third A. Your similarity has been proven. Equiangular. Guys. All three. Therefore, we just conclude. Therefore, triangled. Go back to that order. Triangle ABO is similar. I see 90s too. I see hundreds. Hey, triangle ABO is similar to triangle POQ. Oh, sorry. Triangle PQO. No caps. Triangle. Sorry, let me rewrite this. Very untidy. Triangle ABO is similar. I'm just going back to this order, writing things exactly as I see them. PQO. Then I write the case. Angle. Okay. This is a beautiful way to prove that the triangles are similar. The minute you say something is equiangular, then it means that thing is similar. And if it is equiangular, then it also means that the sides are in the same proportion. If it is equiangular, it is similar. And if it is similar, it is proportional. If it is proportional, it is equiangular. If it is equiangular, it is similar. If it is similar, it is proportional. If it is proportional, it is similar. If it is similar, it is equiangular. It's like they borrow from each other. They go round and round and round. Are you dizzy? 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 Okay. Are you with me, guys? Hi. 4 beautiful marks. Hi, I can get them. Statement and reason, parallel lines in there. 1 mark. Statement and reason, parallel lines in there. 2nd mark. Statement and reason, you. Final conclusion, triangle APO is similar to triangle PQO. You. This guy, yeah. My goodness, guys, so beautiful. Pagati inside. Okay. It is happening. So I come back here. What did I say to you guys? What did I say to? I said, okay, you prove similarity of triangles in 2 ways. Either you prove that corresponding angles, 3 pairs of corresponding angles are equal, or you prove proportional sides. But you can only use this way. You can only use this way, guys, when? You can only use this way when? This is very important. You can't use the idea of proportional sides unless all 3 sides of the 2 triangles, you have them available and they are numbers provided. We don't go down here if we don't have that. We go down here. And it's very easy. It's a matter of just this first and first, we are equal. Second and second, we are equal. Last angle and last angle, we are equal. We need just beautiful reasons that we can come up with from the diagram that basically support the true statement. Because the order in which things are given is exactly how the angles are supposed to be equal. Okay? I hope that makes sense, guys. I forget about me. Okay. I'm going to show you to me. Just wait. There's a second. I will show you guys. Just relax. You need to calm down. Let's finish off the question because it had a second part to this question. The second part of this question says calculate the value of x. What is the second part of the question saying? Calculate the what? The value of what? Of x. So let's go back to the diagram. We are now being asked to calculate what? The value of x. Okay. We have just concluded proving that the two triangles are similar, right? So when the triangles are similar, it goes back to this. What did I say to you guys? The minute we prove that the triangles are similar because of equiangular, then it means that if they are equiangular, then they are also proportional. Because we have proven similarity. Happy birthday, Matilda. I love you. All the best for your test. Love you so much for joining and holding on to the live, even on your special day. Hopefully you'll write like heaven as you write today. Anyways, similarity. You basically share the same birthday month as I do as well, you know. Scorpio, here we go, right? Anyways, equiangular, guys. So if they are equiangular, they are similar. If they are similar, they are equiangular. If they are similar because of equiangular, we know that now we also know that the sides are proportional. Now, guys, because we've proven that the triangles are similar, check me out. Now we can simply go back and say, well, remember, because the triangles are what? Are similar. Triangle ABO is similar to triangle PQO for this reason. Now we can play the eyebrow and the smile. So what you are going to simply do is the following. Listen and observe. Me and you, we want OQ, which is X, right? So it's very important for us to see where is this OQ. There it is. Okay, that is OQ. Okay, the minute, guys, you say the triangles are similar, right? You can say now that the sides are actually in proportion. We've proven similarity, so that means if they are similar, it therefore stands to reason that the sides are in the same proportion. Okay, listen. You can now say QO corresponds with this side, which is what? BO. So me is going to write QO over BO. I'm starting this side. Those will be my numerator values. And then this side, I'm going to write my denominator values. This is my one eyebrow. Last two over last two. The triangles are similar, right? That's what we have just concluded from this. Because the triangles are similar, the sides QO and BO can be written in proportion. QO over BO, okay, is equal to the first two. Look at the first two. PQ and AB. PQ over AB. And the last thing, the smile. PO over AO. PO over AO. Why, guys, are we saying that the sides are in proportion? It's because of similar triangles. We have just proven that the triangles are similar. Therefore, the sides can be written in proportion. Last 2 over last 2. Here's the first fraction. First 2 over first 2. Here's the second fraction. The smile over the smile. PO over AO. Okay, does that make sense, guys? But remember, they want me to find the value of x, which is OQ. Now, the OQ is there in the numerator. So I'm going to now substitute the values that I have. That means x over, where's BO? Let's check. BO is actually equal to 5 centimeters. So it's x over 5 equal. Where's PQ? PQ is here. We have nothing. So let's just wait a minute before we even go ahead and start putting in this fraction. By the way, we need to choose 2 fractions to solve. Okay, after putting 3 fractions and writing them that they are in proportion, we then choose 2 of these so that we can solve for QO. So we already have QO over BO. The question is, which 2 fractions can we then also include so that we can solve for x? Now, PQ is not there. We don't know what PQ is, so I'm not going to waste my time. What about AB? AB is there. But this fraction, it's going to be out for a moment. Let's go to PO over AO. Where is PO? Here is PO. PO is 12 over. So I'm taking this guy and I'm taking this one. These 2 are the 2 that I'm going to choose to equate and solve for my unknown. Where is AO? AO is 6. There is 6. Then I can solve for x from here. This is x over 5. It is equal to 12 over 6. So I'm going to cross multiply the 5 that I have there in the denominator. 12 times the 5 divided by 6. Take my calculator, punch it in. 12 times 5 is 60. 60 divided by 6 becomes what? It is 10. All right. Rin. Oh my goodness. Okay, I guess I didn't upload that video. I forgot actually, because it was the only sort of like on the side video that I did. Yeah. Thing is, Rin, someone like you came into my live session yesterday and interrupted my paper 2 explanations. And I ended up having to spend like a few minutes explaining straight lines and all of that stuff. So I'm guessing I'm going to have to do that for you then. I'm going to have to do that for you. Yes, Rati. Yes. We do exactly this. So the first 2 over the first 2, the last 2 over the last 2, the smile over the smile is the setup of the 3 fractions, because we've just proven that triangles are similar. And we know that when triangles are similar, our sides can be written in proportion, in the same ratio. The ratios are equal. But after writing all 3 ratios, we choose only 2 so that we can solve for our unknown x. So in this situation, QO over BO, we choose this fraction because the QO or the x that we want is there. over 5 because BO is 5 equal to PQ and AB. We eliminate because PQ we don't have. So we take this last fraction, PO, we have PO, over AO, we have AO, it's 6. Then x over 5 is equal to 12 over 6, this fraction. We then cross multiply and solve. We get x is equal to 10. Then what? 10 centimeters. That is the value of x. Okay, right. So please guys, when triangles are similar, I repeat, when you prove that triangles are similar, you can now then, if you prove triangles are similar using angles, you can now proceed and write the sides in the same proportion as you see me right here. Because of similar triangles, you then solve for the unknown. You get the value of x because you choose two of the ratios that have enough information with the unknown that you still are looking for, so that you can solve for that. And that basically is that. Okay. So guys, that basically puts the cap a little bit on similar triangles, and I just want to attend to the scenario where you can only prove similarity using proportion. Let us say, for argument's sake, you were given two triangles like this. Okay, let's just say, for argument's sake, you were given two triangles like this. And then they said to you, prove that these two triangles are similar. Okay, maybe they said, prove triangle BMS is similar to triangle TNP. Let's say they said that. Now, of course, guys, you would look at these two triangles, and the first question would be, how can we prove the similarity of two triangles? Now, you know one of two ways. We can either use equiangular, or you could use proportional sides. You could use equiangular, or you could use proportional sides. But for your scenario here, what are you going to definitely use? Remember, we said proportional sides can only be used when we have all the numerical sides for both triangles. So in this situation, using angles is not going to work, but using proportional sides is going to definitely work. So what you are going to do is you're going to have a lineup of ratios, and you are going to write these ratios separately. So if you look at the order of the letters here, BM over TN. Okay, if we can take BM and divide it by TN, where is BM? Here is BM. Where is TN? Sorry, where is BM? There is BM. Where is TN? There is TN. So BM is 3, TN is 6. If you simplify this, you get half. That's my first ratio. Look at the MS and the NP. So we say MS over NP. What do we get there? MS is 4. NP is 8. What's 4 divided by 8 is simplified? It's half. That's my second ratio. Third ratio, BS over TP. BS over TP. BS over TP. What is BS? It is 5. What is TP? It is 10. What is 5 over 10? It is also half. So what do you notice about your three ratios? Okay, they are the same. In other words, your ratios, all three, all right, are in the same proportion. The corresponding sides are in the same proportion. So therefore we can conclude triangle BMS is similar to triangle TNP. What is the reason? Corresponding sides in proportion. And that's it. Done and dusted. So that is how we prove the similarity of triangles using the sides, guys. That is how we use, or that is how we solve or find or prove the similarity of triangles using the sides. But we need to have all the sides given to us in order to prove that similarity of triangles. All right, please, guys, if that is not the case, then we don't use sides to prove the similarity of those triangles. Okay, hopefully that serves that nice purpose, and you guys are sorted as far as at least having a little bit more for tomorrow. Okay, all right. Yeah, clock it, super clock it. We're locking in. Okay, yes, I'm done, guys. I need you guys to also rest so that you can recuperate, refresh, renew mind, get a little bit of sleep, and all of that stuff. Okay, so please, guys, it was very nice. I really appreciate. Thank you, Bubbles, my twin. Some of you are very generous in your comments. I really appreciated that. Okay, Father God, I really appreciate the time that I've had to just be in the presence of these learners, to get the opportunity to share a little bit of the expertise that you have so gracefully graced me with. I really appreciate their attentiveness. I appreciate them being here. I appreciate their participation, them being active in the comment section, them asking questions when they are lost, even though sometimes I'm sure I'm probably explaining things over their head and some of the things don't really make sense that well. But I just hope and pray, Father God, that where I'm weak, you'll be strong. That where there's insufficiency, you will be all sufficient. Where there is lack, that you will definitely be the one that makes things whole. Bless them, grant unto them strength, give them grace, especially those who are writing in the early hours or the hours of this morning at 9 a.m. when they settle into the venue, Father God, and as they write, may your divine presence, your holy angels, absolute calm, peace, no fear, no limits, may it be attended, may it attend them so that they can be able to do well. I know that you are able. All things are possible with you. We cannot accomplish nothing without you. And please bless crazy Han Matilda, whose birthday it is. May she grow up to be wise in decision making. May she be able to have the wisdom in her youth to be able to do and make those choices that will be pleasing to you. And may she be strong, secure, blessed, wise, prosperous, and all things good. And this is my humble prayer in the mighty name of your Son, Jesus Christ. Amen and amen and amen. Thank you so much, guys, for joining in. It was much appreciated. You guys, were really great sports. I'll post this video there. It is, like I said, these were just various papers all over the show. Nothing really orchestrated, because as people asked questions, I just had to attend to the need and serve the need as it was needed at the time. So thank you so much, guys, again. It was great. I also need to rest and sleep. And honestly speaking, yeah, very, very, very tired. That's for sure. Okay, take care and lots of love to you guys. I'm praying for you even as we continue, just continue pushing on, pressing on. And thank you, thank you, thank you.